Welcome to Geometry Pre-AP, the best subject in the world. Today we're going to learn about the arc length of a circle and the area of a sector. These are new topics in Geometry Pre-AP, so take good notes here. It'll probably really help you. So the first thing today I want to go over is just pause the video and I want you to read this question and I want you to take these numbers and put them in the words exact or not exact. So take a minute, pause the video, and put those numbers down at the bottom into a box for exact or not exact. Okay, so now that you've done this, to get you the right answers, the exact answers are 21 pi, pi over 4, and 23.5 pi. And the not exact answers are like 246.34, 3/5, and 265. And you may be asking, why are these exact and why are those not exact? And the problem here is that you probably haven't really read the question carefully. It says these numbers represent circumference, and circumference is 2 pi r. And so if I want an exact answer, we have to go over the question is, what is pi? Pi is equal to what? Well, some people it's 3.14159, 22 over 7, 3.14, or just 3. It could be any of these things. But all of these things are approximations and roundings, so none of those are exact. The only way you can be exact is if you use the symbol pi. And so this circumference of 246.34 has pi multiplied in it and rounded to the 2 decimal places. This one has pi in it, but it's rounded to a fraction. This one has pi in it, rounded to a whole number. Only these three over here represent an exact answer. So remember that when you're doing answers. A lot of our answers are going to be exact. We don't really want approximations. We want to be able to do this without a calculator if we have to. All right, so our first formula here is circumference is diameter times pi or 2 pi r. How do you know which one to use? It depends on the situation and whether the problem's asking it gives you diameter or whether it gives you circumference. Remember that diameter is equal to 2 times the radius though. Okay? All right, and so here we have our first three practice problems. It says find the circumference, find the circumference, and find the circumference. So if we look at the first one, always write your formulas. So circumference is equal to, we're going to use 2 pi r here because this is my radius. So circumference is equal to 2 pi times 8. And so my answer here is 16 pi feet. Because this is circumference, it's in a single unit. All right, so I want you to do this one right here. Pause the video, do that one real quick, and then turn the video back on when you're ready to check your answer. All right, so for circumference for this one, it's just going to be 13 pi because they gave you the diameter. All right, and this last one, circumference is what they give you, and they ask you to find the right radius. So since circumference is equal to 2 pi r, that means 25 equals 2 pi r. We want to get radius alone, so divide by 2 pi, divide by 2 pi. And so then we get here, those cancel here, and so the radius is equal to 25 divided by 2 pi. This is an exact answer. It's going to have inches on it, and so those are my units, and that's how I want to write my answer. An important thing to note is that the pi is in the denominator here. If you write your answer as 25 over 2 with a pi out to the side, you don't know where the pi belongs. And so you better either put it in the denominator or the numerator, and it matters where you put it. So you better look out. This is wrong. Okay? All right. So a little information about circles before we move into teaching the curriculum is that you need to understand what an arc is and what a minor and major arc is, because that information will be asked of you. Angles are measured in angular degrees, and angles don't go above 180. And circles are measured in circular degrees, and we know there's 360 degrees in a circle. So a circle has, oh, that's not a good color to use. A circle has 360 degrees, but that's not angular degrees, that's circular degrees, okay? And so an arc is like the crust of a pizza. So if I look over here, this is arc AB right there. And so we know, according to this, says an arc is a part of the circle. Arcs are measured in degrees. Their length is measured in units. And so we're going to be really talking about length in here, but you got to know about the measure of an arc. All right, and so we know that according to this, if we have a central angle, that's an angle for a circle, that's vertex is in the center, the angle is equal to the intercepted arc. And now we have two types of arcs still. We have the minor arc and we have the major arc. The minor arcs are less than 180. So if I look up here in this picture, AB from here to here would be a minor arc because it's less than a circle. We want to go the fastest way around a circle, not the longest way. And so when we have this major arc, ABC, it's going from A to B all the way to C, and we can see that's greater than 180 degrees. And the B is like just a point to where we go to before we get to the end point. So just follow the order around a circle, and that'll give you your arcs. There is one other kind of arc that we talk about, which is semicircle, and it's just an arc that's equal to 180. We'll use that later on in the year. All right, so when we're teaching this material, this is our corollary, and this is all we're going to learn. You learned part over whole in junior high, and you learned that if you have a part over whole, you can use that in your is over your percentage of problems. And so that's the key to everything we do. We have part over whole and part over whole. The relationship for the length of an arc, that's the length of that piece right there, AB, is a proportional relationship. And so that proportional relationship is a lot easier to remember than this whole entire formula up here at the top, which I've already had you work on. So what it is we know that there's a whole 360 degrees in a circle, and the part would be the measure of the arc we're dealing with. So this is the measure of the arc, whatever happens, in minor, major, it doesn't matter. And that's the part of the whole relationships here. The other part in whole relationship is the length of the arc, which is the part, and then the whole circles is the circumference of the circle. And so we can take that out and replace that with 2 pi r, or we can replace it with d pi. And this is the formula we have to know. All right, so then we go into our first example. So again, it's a proportional relationship. So start off with your proportion, always. We're going to do the part, which is this, because we're looking for arc AB's length. We're going to do 60 degrees over 360. We're going to do the arc length, which we do not know, over the whole circumference. And since this is a radius, I'm going to use the 2 times pi times a radius of 6. Now you have proportion. Before you start working your proportions, simplify. It's always easier that way. And so we can cancel out this by dividing by 10, and we divide the top and bottom here, and we get 1 over 6. There's nothing we can do over here on the right side, so then we leave it alone. So we got 1 over 6 equals x over 12 pi. Cross multiply. That's a pi there. 6x is equal to 12 pi. Divide by 6, and so x is equal to 2 pi. And then we go with our units, centimeters, because this is a length. And so that's our proportional relationship, and this is an exact answer. We want to have as exact as often as we can. All right, so here's another problem. You'll notice we have a 12 meters out here. That is not the circumference of the circle. That is the length of that arc, and so that is the part. So we go with our proportion, 80 degrees out of 360, and then we have 12 out of, now this asks for a radius, so we're going to put 2 pi r in here. Now, like I said earlier, before you start working a problem, always simplify when you can. It makes the work easier here. So 4 goes in this 9 times, 4 goes in at 2 times. This 12 and this 2 can cancel, be a 1 and a 6. And once I have that simplified, now you can cross multiply. So 2 pi r equals 6 times 9. Remember that I don't like to multiply our numbers out because it just makes it easier to simplify them later. Next step, we're going to divide by the 2 pi because we're trying to get radius alone. This 2 and this 6 will cancel to be a 3 left, and I get 27 over pi. And of course, we need some units here. All right, and so that is our answer. Remember, I told you it's important to know where the pi symbol is, whether it's in the numerator or the denominator. Look carefully to see where it is when you're solving the problem. All right, so this next problem over here to the side, I want you to do. So pause the video, work this problem, and then turn the video back on when you're ready to check your answer. All right, so you should have done this problem by now, and here is your answer. You should be getting 12 feet. If you have problems with this question, we'll go over it when you get back into class. So, but make sure you have an attempt, have your proportional relationship set up. I'll give you a hint here if you had a problem doing this one. I don't use this angle. I need this arc out here. So I need the other side of the circle. All right, so a little situational problem here. This one, it says we want to find the perimeter of the shaded figure. So we want to know this figure right here. That's a little too far. So we want this blue lined figure here that I just outlined in blue. So I'll tell you what, the easiest part would be to add the two sixes together. So that's 6 plus 6. But we need this piece here and this piece here. So we're going to have to find the length of this. Now, they both have the same radius. So if we find one, we could probably get both of them just by doubling it. So we want to do our proportional relationship. That's 90 out of 360 equals unknown length out of the circumference, which would be 6 pi, 2 times 3. These cancel to be 1/4. I get 4x equals 6 pi. X is equal to 6 pi over 4. Now that can be reduced. That's 3 pi over 2. Remember, that was only one side. We want to double that, which gets us, these cancel, 3 pi. So we're going to have 6 plus 6 plus 3 pi, which we can simplify that as 12 plus 3 pi. And of course, that would be the perimeter of our shape here. And don't forget our units, which is just units in general. And that's our perimeter. You'll have a lot more problems like that when you do it in your homework. All right, and that brings us to the end of the first half of this lesson. Now we move on to the second half, which is now we're going to find the area of circles and sectors. So if the arc is like the crust of the pizza, the sector area is, let me get this off there, is like the area of the pie itself. So it's like the slice of the pizza where the crust is the arc, and this is the sector. All right, and so we have a little formula for the area of a circle. Area is equal to pi r squared. And so make sure you memorize that formula. You'll need it all the time in your work. And here we have our first little example for area. I put it a fraction in here just because I want to make sure that you work with fractions. So area is equal to pi r squared. If you want to pause the video and do this one, you can. And then you can turn the video back on and look at what the answer is. So area is equal to pi 7 over 3 squared. Area is equal to pi times 49 over 9. And area is equal to 49 pi over 9. If you wrote your answer as 49 over 9 pi, this will be considered wrong. If you don't put that pi in the numerator, remember what I said earlier, you have to put the pi in the right place. In other words, it doesn't. You don't know where it should be, was the numerator, denominator, and it's going to be confusing. So either put the numerator, denominator, does not belong in the denominator here, it belongs in the numerator. Think of that pi as pi over 1. All right, so here we have the sector area formulas. Okay, and so for these, it's the same little setup, part over whole, part over whole. So it's the same proportional relationship like an arc length, but now we're talking about the area of the sector. So now we look over here, we got the measure of the arc over the whole 360. And now we have the area of the sector, which is our part. And because this is area of sector, we're using the area of the circle now, which is pi r squared. Same setup, just that we've changed to an area formula instead of a length formula. So we go into this first practice problem. Proportional relationships, set your proportion up. We're doing the shaded area, which makes a difference. Pay attention to that. I might catch you on that if you don't. And so 100 is the part over the 360 degrees, which is a whole. And then we don't know the area of the sector, and then the whole will be pi 5 squared. So before I start multiplying things out, I simplify here, and I simplify here again. 2 goes to that 5 times 2 goes to that 18. So we have 5 over 18. So 5 over 18 equals x over 25 pi. And so that's 18x equals 125 pi. Divide by 18, divide by 18. I cannot simplify that, so my arc is 125 pi all over 18. Since there's no units, we'll just use the common units squared. This is area, so we use units squared. Okay. This second one over here is for you. You want to pause the video, work this problem, and then turn the video back on, and I'll have the answer for you. All right, so if you work this problem, your answer for your area of your sector this time, so your area will equal 28 pi over 9. If you got this one wrong, make sure you pay attention that I wanted the shaded area, this part this time, not the 80-degree part. So remember that this is the other part that's left of the 80 degrees. That might help you if you set it up wrong. All right, so we got two problems. Well, we got three problems left, but this first one I'm going to do with you. This is a little bit more intense work where you're finding an unknown variable in a different place. So again, it's a proportional relationship. Always set your proportion up. We want the shaded part, so if this part's 30, the unshaded part's 330 degrees. That's 360 minus the 30. So 330 degrees over 360 part over whole. This area represents the area of the sector, not the area of the circle, but the sector. And then our unknown, we're trying to find radius, so we're using pi r squared. First thing you want to do once you set your proportion up is simplify what you can. Those pi's cancel. That's a nice thing. The zeros canceled there. 3 goes in this 11 times. 3 goes into this 12 times. So let's rewrite that. 11 over 12 equals 60 over r squared. Cross multiply, that's 11r squared equals 12 times 60. Okay, divide by 11, divide by 11. R squared equals 12 times 60 divided by 11. Last step is to square root this, and this is where we get back into our old algebra work. So the first thing I want to do is I want to simplify what I can. So remember, 12 is 4 times 3. 60 is 4 times 15. So if I can take out that 4, that gives me a 2 on the outside. That one gives me a 2 on the outside, but now I've got a 3 and a 15 left. Well, the 15 is 3 times 5. So I've got that 3 and that 3 that cancel out to give me another 3 on the outside, with a square root of 5 left behind and a square root of 11 in the denominator. So as I simplify this, I get 2 times 2, which is 4, 4 times 3, which is 12. I got 12 square root of 5 all over the square root of 11. Now remember, you have to rationalize the denominator, so we have to get rid of that out of the denominator. So 12 square root of 55 all over 11 is our exact radius. And of course, this will be inches. For the next problem, you want to pause the video. Do notice that if you're using the paper notes that I've changed the area of that sector to 20 instead of the original 80. It'll make a little bit different answer. I'll put both answers up when you're done. All right, so now that you've attempted this problem, when you're done working this problem, your radius is going to equal 6 square root of 5 pi all over pi. You can't have that radical square root of pi in the denominator, so you have to rationalize that denominator. Now, if you did this problem with the page in class, that area was a 80. So if you did it with the area was 80 for that part, your answer that you would have gotten would have been 12 square root of 5 pi all over pi. But since you're watching the video, you should have been doing it with this number, and so you should get this answer. All right, we got one last problem. We want to find that shaded little slice out there. And so to find this shaded little slice, what I need to realize is I need the whole entire slice first. So if I can find that red slice, that's great. And then once I have the red slice, if I can take away this little area of this triangle here, I'll have what's left. So you've done some of this kind of work in the previous units. So let's start with the proportional relationship, figure out the whole entire slice first. So that's 90 out of 360 equals the area of that sector out of the area of the whole circle, which is 8 squared times pi. So this reduces to 1/4. I get 4x equals 64 pi. Divide by 4, x is equal to 16 pi. So that is the area of the whole entire red piece. Now I need the area of this triangle. Remember, the radius in a triangle is congruent. So if that's 8, this is 8. So the area of the triangle is equal to 1/2 base times height. That's 1/2 8 times 8. What I end up here is with this 32 for the area of the triangle. So I'm going to take the area of the sector, which is 16 pi, and I'm going to subtract the area of the triangle, which is 32. And this is my exact answer in feet squared. So this is the area of that little piece. All right. You'll have homework to practice. You'll want to do the odds, and then the next day we'll be doing the evens. If you understand a section, move past that section and do a different section. Good luck on your homework. Make sure you write questions down as you run into problems.